So we did examples 1 and 2 on the coordinate proofs notes yesterday. We're going to do example number 3, and then you guys are going to have the rest of the class period to work on the homework so you can have it turned in by the end of the period. Okay, thank you. Yeah, we're doing that right there. So there are 3 things that we have to find and compare. First thing we need to do, though, is to plot our points and connect the dots to make a quadrilateral, a 4-sided figure. So let's plot our points. J is negative 5, 1. K is 1, 4. L is 4, negative 2. And M is negative 2, negative 5. And then we will connect those 4 points together. The 3 things that we're going to have to find and compare are going to use the midpoint formula, slope formula, and distance formula. And we're going to do that with what parts of this quadrilateral? The diagonals, yes. So what points should I connect to draw in the diagonals here? JL and KM. So after I get my shape graphed and I've drawn in those diagonals, first thing I'm going to do is write down what those diagonals are. Diagonals of JL and KM. So we need to find the midpoint for both of these and compare them to see if they're the same. So midpoints. So big capital M, we're going to find the midpoint of JL first. So I'm going to look at points J and L only. So here's point J and point L. We have to pick one of these two to be my point 1 and the other one to be point 2 so that I can get an x1, y1 and an x2, y2. Do you want point J to be point 1 or point 2? Sounds good. So this is going to be my x1, y1. And so L is my x2, y2. To find the midpoint, we add the x's, then we cut them in half. And then we add the y's and cut them in half so that we can get an ordered pair here. So I'm going to add my 2 x's together, negative 5 and 4. So negative 5 plus 4, and then we divide that by 2. And then we do the same thing for our y's. We add those together, so 1 plus negative 2. We divide that by 2. And now we have to simplify this so that we get a single value. What is negative 5 plus 4? Negative 1. What is negative 1 divided by 2? Negative 0.5. What is 1 plus negative 2? Negative 1 divided by 2? Negative 0.5. Yeah. And now we're going to find the midpoint for KM. So big capital M for midpoint for segment KM. So now I'm looking at just these 2 points, K and M. Once again, I need to pick out a point 1 and a point 2. Do you want K to be point 1 or point 2? Sounds good. So this is my x1, y1 here with K. And M would be my x2, y2. It does not matter which one you call point 1 or point 2. All right, so to find the midpoint, we're going to add the x's. My x's are 1 and negative 2. So 1 plus negative 2, and then we're going to divide that by 2. And then we add our y's. 4 plus negative 5. And we divide that by 2. You guys already told me this a moment ago, but what is 1 plus negative 2? What is 1 plus negative 1 divided by 2? What is negative 1 divided by 2? Negative 0.5. And what is 4 plus negative 5? Negative 1, and then we divide that by 2. So we get another negative 0.5. So looking at these two midpoints, what do you notice? They are the same. Since my midpoints are the same, what does that mean? Yes, the diagonals bisect each other. Which means this is definitely what kind of shape? Definitely a parallelogram. So I'm going to come over here. Right here is where my diagonals are crossing. That does look to be about negative 0.5, negative 0.5. So JL is being cut in half by that midpoint. And KM is also being cut in half by that midpoint. So we know this is definitely a parallelogram. I need to know if it's an even more specialized type of shape. So we're going to check to see if this is a rectangle, a rhombus, or a square now, because all three of those are special types of parallelograms. Next thing we're going to check is the slopes. So we're going to find the slope of JL, so lowercase m now. To find the slope, we do y2 minus y1 over x2 minus x1. So I'm looking at my blue circled points here. Y2 is negative 2 minus y1, which is 1. And then my denominator is x2 minus x1. x2 is 4 minus x1, which is negative 5. So then I simplify my numerator. What is negative 2 minus 1? Negative 3. So negative 3 in my numerator. What happens in the denominator where we subtract a negative? They add. So 4 plus 5 would be 9. Negative 3 over 9. Can I reduce that at all? Is there anything that goes into both of those? 3 goes into both. So we're going to divide top and bottom by 3. What is negative 3 divided by 3? 1. So I have negative 1 over 9 divided by 3? 3. Positive 3. There we go. So my slope for JK is negative 1 over 3. Then we're going to find the slope, so lowercase m, of segment KM. So now I'm looking at the red underlined points, and we do y2 minus y1 first. y2 is negative 5 minus y1, which is 4, over x2, which is negative 2, minus x1, which is 1. What is negative 5 minus 4? Negative 9. And negative 2 minus 1? Negative 3. What happens when you divide a negative by another negative? Becomes a positive. So this would actually be positive 9 over 3. And can I reduce that at all? By what? By 3. Divide top and bottom by 3. 9 divided by 3 would give me 3. And 3 divided by 3 gives me 1. So I can write this fraction, this slope, as 3 over 1, or we could just write it as the whole number 3. I'm going to write it like this, though, because it lets me compare to the other slope a little bit easier. So I want to know whether or not these are opposite reciprocals. Opposite means opposite signs. One's positive, one's negative. Yeah. Yes. And reciprocal means that one, the fraction of one, looks just like the other except flipped over. It's the same two numbers, but in the opposite position. So is this fraction The same as this fraction, but flipped over. Yes, it is. We're not paying attention to the positive negative part. That's what the opposite part means. Reciprocal, I'm just looking at the actual fraction itself, just those two numbers, not positive or negative. So these are opposite reciprocals. Because they are opposite reciprocals, that means what about my diagonals? They're perpendicular. My diagonals are perpendicular. So here, right in the center of this shape, right near where that midpoint is, these are 4 right angles in here. All right. Because my slopes are perpendicular, not my slopes, because my diagonals are perpendicular, the slopes are opposite reciprocals. That means this could be which shapes? There's 2 options. Could be a square. Which other one has perpendicular diagonals? A rhombus. So this shape here is either a square or a rhombus. I'm going to be able to decide the difference between those because if the diagonals are the same size, they're congruent, then it's a square. And if the diagonals are different sizes, then it is a rhombus. So the next thing we're going to check is our distances, and this is the last thing we have to calculate. So big capital D for distance. We're going to find the distance of segment JK. So we need a big old long square root sign. We do x2 minus x1. I'm looking at my blue points. Oh, I wrote JK and it should be JL. I'm sorry, I did that on the one up above too. It should be JL. It's the other point that has K, or the other diagonal that has K. Looking at points J and L. x2 minus x1. So x2 is 4. Minus x1. x1 is negative 5. So 4 minus negative 5, and then square it. Plus, and now we do the same thing with our y's. y2, which is negative 2, minus y1, which is 1. Close the parentheses and square it. You guys already answered this for me once, but what happens here when I'm subtracting this negative? Turns into addition, turns into positive. So I have 4 plus 5 here. What is 4 plus 5? 9. So I have 9 squared plus, what is negative 2 minus 1? Negative 3. So I have 9 squared plus negative 3 squared. What is 9 squared? 81. Plus, be careful here. Negative 3 squared. What's it mean to square something again? Times it by itself. So I'm doing negative 3 times another negative 3. What is a negative times a negative? Positive. So what is negative 3 squared? Positive 9. And 81 plus 9? 90. So underneath the square root, I have 90. If I take the square root of 90, will it come out to be a nice, pretty whole number? Then I'm just going to leave it like this, because remember, all I need to do is compare it to the other one and see if it's the same or different. So now we're going to find the distance, or the length, of segment KM. So big capital D, segment KM. Big old square root sign. x2 minus x1. I'm looking at my red points now. x2 is negative 2 minus x1, which is 1. So negative 2 minus 1, close my parentheses and square it. Plus, and now we do y2, which is negative 5. minus y1, which is 4. Close my parentheses and square it. What is negative 2 minus 1? Negative 3. So negative 3 squared. Thank you, ma'am. And negative 5 minus 4? Negative 9. So negative 3 squared plus negative 9 squared. What is negative 3 squared? 9. Plus negative 9 squared would be 81. And 9 plus 81 is 90. So talk to me about the lengths. They are the same. So this tells me what about my diagonals? They are congruent, yes. And Denai, you said that means this has to be what kind of a shape? This has to be a square. JKLM is a square. Because the diagonals bisect each other. They are perpendicular. And they are congruent. So we got all the things going on here. So for every single one of these problems, for all the ones that are on your homework, draw your shape. So plot your points, draw your shape, draw in your diagonals. And then you're going to have to find these 3 things about both diagonals. You have to find both midpoints. You have to find both slopes. You have to find both lengths or distances. For slopes, you want them to be not the same, but opposite reciprocal. For midpoints and for lengths, you want them to be the same. You guys have the rest of the class period to work on the homework. When you get it finished, you can turn it into the tray. And please let me know if you have any questions or if you get stuck on anything.